Hi, everyone. I just wanted to take you through some steps for your transformations where we are going to put more than one transformation together. So you've been practicing with a single transformation. So all we're going to do is those same transformations, the same rules, except now we will look at putting more than one into the same problem. So the first thing that I want you to look at is the transformations overview Google Doc that was shared with you. This is really, really nice because it puts together every single one of those transformations. So if you're asked to do a 90-degree counterclockwise rotation, here he is, 90 degrees counterclockwise. There's your pattern, the opposite of y, comma, x. That's the pattern that, or the rule that you're going to fill into. Really, really nice document to have. If you have a printer, print it and keep it handy. If you don't have a printer, keep that tab open and just keep referring back to it. That's what I'm going to do so you guys can see it. So here I have some problems, and this is not an assignment that you had. It's just some random problems that I'm going to take a look at. So what we're going to do is one transformation, and then we're going to see how it is going to translate into more than one. So first one asks us to translate this triangle by this rule. A couple things with this, when it's written this way, it's a little bit more obvious what you're going to do. You are going to subtract 3 from all of the x's. If I take a look to my transformations sheet, I am subtracting from my x's. Notice subtracting from the x's is actually moving left. You will have assignments where it has it written as that rule, or it tells you to move an object left. If it tells you to move left, then we know we need to subtract. So technically this is moving our figure left 3 units. So I'm just going to do the x's for now. I'm going to subtract 3 from each one of these x values. So 4 minus 3 is 1. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. Again, that would be moving left 3. Y minus 4, again, just to point this out, minus 4, you're subtracting from the y's. Therefore, you are moving down. So this is another way of saying move down 4 units. Take these y's, subtract 4. So 1 minus 4 is negative 3. Negative 2 minus 4 is negative 6. And 3 minus 4 is negative 1. There's one transformation. And if you notice, these ordered pairs are exactly the ones that are here, which is the next problem that we're going to look at together. So in that, it now wants us to take this same triangle, and now it wants us to reflect it over the x-axis. So again, if you're not sure what the rule is for an x-axis reflection, go back to that sheet. An x-axis reflection, keep x the same, and then you're going to take the opposite of the y value. So x opposite of y. So I'm using these ordered pairs here, which they did right there again for us, which shows we did get them correct. X isn't changing, so that stays 1. The opposite of the y value, y is negative 3. It's going to become positive 3. Negative 2 stays negative 2. Want the opposite of the y value, opposite of negative 6 is 6. Keep x negative 1, opposite of the negative 1 for y is a positive 1. There's 2 transformations done to that same set of ordered pairs. So how it's going to look with some of the other problems, if we actually put those together in one, I'm going to take a look at letter B here. It asks me to first reflect over the x-axis. So x-axis reflection, if you take a look, x-axis reflection again, x opposite of y. So x opposite of y, let's fill them in. T, 2 stays the x, opposite of 3, negative 3. 1 for the x, the opposite of 1 is negative 1. And for B, the x stays 4, opposite of negative 3 becomes a positive 3. And now it wants to reflect over the y-axis. So let's go back and take a look to reflect over the y-axis. This time we take the opposite of the x coordinate and y stays the same. So opposite of x, comma, y. Use these ordered pairs here in green, not these original ones. We can forget about those guys. We're using the ones from the step before. Notice that this time it's t called double prime because this is the second transformation that's being made. So x starts as 2, but we want the opposite, so it will be -2. The y stays -3. Opposite of 1 becomes -1. The y stays the same, so it stays -1. 4, but we want the opposite, so -4, and the y stays the same. You did 2 transformations. Each one was a reflection, 2 transformations together there. Again, just big thing I can say is keep referring back to that transformations overview to help you out until maybe you're a little bit more comfortable with those translations. Another one, if we take a look at it, I'm going to take a look at one of the rotations because I do know that that's one thing that we is a little bit weird for us. So if we take a look at the next one, I'm going to do this letter D. So it says to reflect it over the x-axis. Again, we just saw that in one of those problems above. X-axis is x opposite of y. If you don't remember, refer back to that sheet. So x's are staying the same. So the x value of t is 2. Opposite of the 3 becomes a -3. For for A, 1 stays 1. And then the opposite of 1, we now have -1. 4 stays 4. Opposite of -3 becomes +3. There's your x-axis reflection. Now, let's take a look at your rotation. So this is a 90-degree clockwise rotation. So I'm not sure exactly what that rule is. Go back and look. 90-degree clockwise. Here it is. So going to use y, comma, the opposite of x. So y, opposite of x. Again, we're using these ordered pairs, the blue ones, for our next transformation. So again, forget about these given ordered pairs. The y value coming in first. Well, the y value is -3. Drop it in first into the ordered pair. And then we want the opposite of the x. Well, the x starts as 2. So that now becomes -2. For A, y value comes first. The y is -1. The x is 1, but we want the opposite of it, so -1. And for B double prime, y value comes first. Well, the y value is 3. And then the opposite of the x. The x starts as 4, so we're now at -4. So again, more than one transformation at a time. No big deal. Just keep going. So we've done pretty much every one except for these dilations. So if I take a look, let's say I add a step to this one and I say, hey, let's dilate by a scale factor of 2. Remember, for dilations, we multiply both the x and the y coordinate by the scale factor. So scale factor 2, we would multiply. Since this is our third change, this would be t triple prime. Multiply everything by 2. -3 times 2 is -6. -2 times 2, -4. A triple prime would be multiplied by 2, -1 times 2, -2, and same thing for the y value. And B triple prime, multiply 3 by 2 is 6, multiply -4 by 2 is your -8. So we can keep translating it. Let's go one more because we'll put another step in here because it's exactly the same stuff. Let's say now I want you to move up 3 units. Take a look back. Moving up 3 means I'm going to add to the y. So to move up 3, I'm going to do y plus 3. X's will stay the same. So this will be now t quadruple prime, so 4 marks because this is the fourth transformation. T will stay -6. -4 plus 3 is -1. A, X stays the same, -2. -2 plus 3 is 1. And B, -6 stays the same. -8 plus 3 would be -5. We could keep going and keep going and keep going, making one transformation at a time. Again, cannot stress enough looking back to this transformation overview. The more you look back at it, the more you're not going to have to look back at it because those rules are going to become easier and easier each time you do that. So I would, again, suggest using those when you're doing those transformations.